Today, the team at United Silicon Carbide is now Qorvo, is announcing the expansion of its fourth generation 750 volt FET portfolio to include surface mount, with the offering of the new D2PAK 7 lead packages. The new surface mount FETs are offered in 7 different on-resistance levels, ranging from 60 milliohms down to 9 milliohms in an industry standard TU-263 7 lead. These new FETs are a great complement to our through-hole TU-247 lineup, and are attractive choices to lower inductance layouts, simplify assembly, and reduce converter size. And with the industry's lowest on resistance down to 9 milliohms, moving to surface mount no longer means conceding to lower power. The new portfolio of 750 volt D2PAK 7 lead are a great fit for a variety of power applications, including front end and DC-DC stages in server power supplies, as well as on and off board chargers. The parts again offer the industry's lowest RDS(on) times die area and the superior performance figure of merits that this affords. They can be driven with a simple 0 to 12 or 0 to 15 volt gate drive, and they're compatible with silicon, MOSFET, IGBT, or silicon carbide MOSFET gate drive voltages. Their Kelvin source pin allows fast switching with clean gate waveforms. The FETs have an excellent integral diode with a low 1 to 1.5 volt drop and low reverse recovery. Good power handling capability is maintained with an advanced silver sinter die attach, which gives them superior thermal performance despite their smaller die size. The Gen 4 products center around our vertical trench JFET technology. This is the closest to the unipolar limit of silicon carbide. We've introduced a JFET trench structure with reduced cell pitch and optimized drift layers. To go along with the device cell improvements, we've also employed a further reduced substrate thickness to arrive at the industry's best specific on resistance. The Gen 4 750 volt FETs are less than half the specific on resistance of our previous generation JFETs, and roughly 1/3 the on resistance of competing technologies. You can find the new 750 volt surface mount lineup in our free online FET-Jet Calculator. With this tool in our broad portfolio, complete with 7 different on resistances from 9 milliohms up to 60 milliohms, you can optimize your design based on the system constraints that are crucial to your application. You can optimize the performance for efficiency, cost, or thermal management. The results are real time, and you can download and save your designs with no registration required. With our 4th generation cascode FET technology, Qorvo is able to achieve the lowest on resistance for a given footprint. In this chart, we're showing the lowest on resistance FETs in a standard D2 7-lead package. You can see that our new 9 milliohm 750 volt FET is 20% lower than their closest peer. The best-in-class specific on resistance, along with the superior thermal performance of the sinter die attach, allow us to offer these low on-resistance surface mount parts while keeping a high voltage capable package. The Qorvo D2PAK is offered with a robust 6.7 millimeter creepage distance and a 7.3 millimeter clearance distance, which is the best in class, and a single package design can be used from 650 volts all the way to 1700 volts. Perhaps the best way to visualize all the advantages of Qorvo's 750 volt Gen 4 FET technology is with the use of a single radar chart of performance figures of merit. Here we've normalized the Gen 4 silicon carbide FETs to a value of 1 for each parameter, and in each case the smaller number is superior. You can see whether it's the specific on resistance across usable temperature or the much lower integral diode forward drop. The conduction losses of the Gen 4 FETs are superior to competing technologies. With the lower RDS(on) times area, the smaller die sizes can be used, yielding a lower output capacitance for a given on resistance. The Gen 4 FETs are excellent for hard switching with a low RDS(on) times EOSS product. They're also great for high-frequency soft switching circuits afforded by their excellent RDS(on) times COSS time-related product. In this slide, we show a more traditional bar chart view of the 750 volt FET performance figures of merit parameters. Their leading specific on resistance is as low as 0.7 milliohms centimeter squared at room temperature, increasing by less than a factor of 2 up to a practical operating junction temperature of 125 C. One can think of the minimum hard switching energy that must be dissipated in each switching cycle as the energy stored in the device's output capacitance, EOSS. Then we can think of a hard switching technology figure of merit as on resistance times EOSS. Here, the Gen 4 silicon carbide FET's smaller die size yields nearly 50% improvement. For high-frequency soft switching circuits, one may think of RDS on times COSS time related as a good performance figure. A low value of this parameter gives low conduction losses with short delay times when in the presence of small turnoff current. So here the Gen 4 silicon carbide FETs again appear best in class. And their low gate drive voltage and low QG combine to simplify gate driving. These performance benefits come with an excellent integral diode with a low 1 to 1.5 volt drop and a fast low loss recovery, which enables reliable operation even out of resonance. Let's return back to our portfolio and look at a couple case studies comparing our through-hole and surface mount 750 volt product line. Of course, the lower inductance and higher creepage and clearance of the high voltage surface mount package is offset by the smaller die pad and typically higher thermal resistance junction to ambient than you'll find in a TU-247. Here we use simulation to estimate some thermal resistances for TU-247s based on mounting the parts with various ceramic insulators to aluminum heat sinks. As an example, we show the 18 and 44 milliohm parts mounted with alumina, silicon nitride, or aluminum nitride insulators. We see a junction to fluid resistance ranging from about 0.8 degrees C per watt up to about 1.1 degrees C per watt. If we look at the same class parts in the new B7S D2PAK-7L lead option, soldered to an IMS, then we can see an increase in junction to fluid resistance of about 0.5 to 1 degree C per watt compared to the 247 case, but still a manageable value of about 1.3 to 2 degrees C per watt junction to fluid. Assuming a conservative 0.6 degrees C per watt for the through hole and 1.2 degrees C per watt for the surface mount case to fluid, we now use our FET-Jet Calculator to compare the options in a typical 6.6 kilowatt Totem-Pole PFC and isolated DC-DC stage. The FET-Jet is preloaded with the conduction and switching losses versus load and temperature, with the thermal resistance junction to case for our entire product lineup. The switching frequency of the PFC is 75 kilohertz, and the input is 230 volts AC and the output is 400 volts. The chart shows an excellent semiconductor efficiency of over 99% for all of the parts in the lineup, and by looking at the junction temperatures obtained, one can see a wide range of feasible solutions exist. While the surface mount parts offer lower switching losses, generally a lower RDS-on part is required to achieve the same junction temperature as the larger TU-247 product. This chart is a clear example of a wide range of choices to optimize the performance, cost, and thermal design with Qorvo's 750 volt portfolio. A very similar result is observed when looking at the 750 volt portfolio in the 6.6 kilowatt CLLC Isolated DC-DC converter stage. Here we see a wide range of choices offering great performance. But along with the excellent efficiency, these parts come with the added benefit of a simple 0 to 10 volt gate drive possible in these high frequency soft switching circuits. To summarize, Qorvo continues to expand its 750 volt lineup, now offering high performance FETs in both through-hole TU-247 and 7-lead D2PAK surface mount packages that are sure to offer excellent solutions in IT infrastructure and charging applications. As with all of our fourth generation FETs, they feature a very low conduction loss, excellent hard and soft switching performance, and superior thermal resistance. Visit our website and our FET-Jet Calculator to see what the new B7S lineup can do for your application. Thanks for watching from the team at United Silicon Carbide is now Qorvo. And stay tuned as we continue to deliver optimal silicon carbide power solutions for your high growth markets. Thanks for your time, and please visit unitedsic.com for more information about our new silicon carbide FET.